Hi, Marco. Welcome to the Future Proof Operations podcast.
Hello, good to be here.
Marco, great to have you on the show. At the beginning, could you give us a 60 seconds overview of who you are and what you are doing?
My name is Michael Chacin. I lead a group of engineers in Airbus to create motion systems and end-effectors to build aircraft, basically airplane. We work with robots and all kinds of systems to bring together all the pieces and all the parts in Airbus in aircraft manufacturing.
Marco, thanks a lot. Today we want to talk about robotics in aerospace manufacturing, and I know that you have a big passion for it. So my first question is, what inspired your initial interest in robotics, and how has your perspective on that technology evolved over the years?
Well, that's a great question. So I should say that my passion for robotics started as a very young boy. I used to when I was little, I used to watch TV shows for Japanese anime and cartoons with back in the 70s and the 80s, big robots, right? That were fighting big monsters and things like that. And that was what sparked my interest in both the not only the Asian culture, Japanese culture, but also in bigger mechanisms and robots that could enhance human capabilities. So the cartoons that I used to watch were a little bit ahead of my own generation because being from Venezuela, those cartoons were made in Japan and they need to be translated. So I actually watched the cartoons from the 70s in the 80s. But the timing, it was what inspired me and what drove me to become the roboticist I am today.
That's super interesting. So cartoons have a big part of your professional career path in the last years.
Absolutely. I mean, you could say that I'm that kid that actually became what he wanted to be when he was a kid. When he was
Oh,
little, right? You're not.
that's lovely.
I consider myself very lucky in that regard because not everybody has that opportunity. When you're little, you say I want to be a firefighter or you want to be a police or want to be something. When I said I want to become, I actually did. So I'm
Yeah,
considering myself very lucky.
awesome. And if you take a look back into the last 2 decades, what has been the biggest significant change in robotics where you say, oh, this is the wow factor?
So I think that that can be taken in a couple of different directions. So when I two decades ago, it sounds like it sounds like yesterday, but actually time flies really quickly. I moved from Venezuela to Japan to study robotics to get a PhD in robotics. At the time, um, Japan was the number one country in the world in that regard. If I wanted to learn how to make robots and study mechanical engineering, things like that in aerospace, I think Japan was at the top, more or less. I think that's changed over the last 20 years. Not that Japan is still not very good at what they do, but you've seen other players, European players, and also in the Americas come up to speed on not just mechanical engineering, but also AI and software really. So I think that's the first one of the first changes in the dynamics of the markets around the world. And then the other one is um, so for the longest time, we've had robots that like almost two trends. Robots that are really good at doing things physically. And this is where you got your, Hondas or your Agile Robotics or your Boston Dynamics. They build robots that can do pretty amazing things. If you've seen videos in YouTube and the internet, you see robots doing flips. Going up and down stairs. Really doing things that are really really difficult to do and difficult to engineer to actually allow them to do that. However, what you don't see in those videos is the fact that you have somebody behind camera controlling them. Those robots are
Yeah,
not really smart. They're really able physically, but not really smart. Your smart robots, quote unquote, you have them on a different trend, which is your Alexas, your Siris, your Google Homes. And so those are two distinct different trends that we've had over the last few years. And now we're going into that stage in which that phase in which both lines are about to converge. As AI has become really really interesting and really really powerful over the last couple of years, and we still have these robots here that need a brain. So sooner or later, it seems to me that is going to be more sooner than later, that those two lines will converge, and we'll really get to see, the power of AI implemented on a robot that can actually do interesting.
Yeah, awesome. Yeah, this is a super interesting topic. I definitely want to dive deeper into it. Nowadays, if you see some YouTube videos, it seems like some robots have already a brain, and this is already converged. But I don't know if this is already reality or some mock-ups in the videos. Before we dive deeper into this, I would like to understand a little bit better how a usual day looks like in an aerospace manufacturing company or factory. And to understand that, could you describe how a typical day looks like? So if I would go with you in a factory and I would see how a plane is assembled, how many people are working there, how many robotics or robots are there already? How does it look like?
Right. So in any typical aerospace manufacturing facility, first of all, you see probably thousands of people around you. Both Boeing and Airbus have massive amount of people working on their product. Even here, where I'm based in the UK, our plant has just about 7,000 people. Are in the
Crazy.
three shifts. But what you actually see is that, very different from the automotive industry, our processes are still very manual, and this is because our product is very big, right? And when you compare a manufacturing facility from automotive, the probably the biggest element you have there is the chassis of the car, and that won't be more than 2 or 3 meters long. So you can have a configuration in which you have several robots around a cell, have the chassis come in, and then the robots will do the work without without thinking too much about it. The robots are always going to the same positions, doing the same motions, as long as they're configured that way. In aerospace, that is a little bit different, uh, because the product is so big. You need to consider things like thermal expansion and things, right? So the you're not necessarily always doing the operation in the same place. So you need intelligent systems to actually understand where they need to drill, or where they need to fasten, or where they need to paint, or they need to do any other operation that we do. So a lot of those processes are still very challenges for the robots that we have today, and which means that in turn we have a lot of humans in the loop working those small details, because obviously we are a very multifunctional tool as a human, right? We can do whatever we want. So today you see you do see a mix of uh, people working on the product, and also automation systems, but the ratio is very skewed. Still, there's a far more humans in the loop than in other industries, for the reasons I just described.
Okay. So you say there's one challenge, which is the size of the manufacturing part. So it's not easy to automate that. Are there other challenges which are hindering you to automate more, to have more robotics in
Yes.
the factory?
So the other one I could mention, and I kind of alluded to it a minute ago, is, like I said, if you have a cell in the automotive industry where the chassis will come in, and then you have the robots around it, that cell is very likely to be caged. Around that a safety fence that would prevent any human to come in and get injured. In our case, because as a byproduct of the airplane being so big, the part being so big, then robots they need to be able to work together with humans around, and so that add, adds a lot of complexity to the safety system, because the robot not only needs to be aware of where to drill, or where to fasten, or where to paint, or where to sand, but also that there potentially be a human in another area of the aircraft that could be closer to the robot itself, that also needs to be protected. So safety is probably the one of the most challenging aspects of making sure that robots can work together with humans in order to make aircraft. And then perhaps the other one is precision or accuracy of the operation. Today,
Yeah, okay.
we have humans um, that can do well. Speed is one thing, and I mentioned that in a second. But today we help the human operators that using almost like something that we call a template. So if you need to drill a specific position, you basically first put a template on the part, and that will guide where you need to insert the drill. very quite simple. You just follow the instructions on the template and that's it. The robot won't use that. So, but the robot needs to be very, very accurate in order to do the operation exactly in the place where it needs to be. So that needs a lot of, another layer of sensors and understanding of the product, and actually in order to do this. And then the speed of the operation is perhaps another one of the challenges. We don't have the cycle times or the operation time that the automotive industry has. Take for example the number one manufacturing in cars. They produce millions of cars every year. So they pump out of their production lines 9 million, 10 million cars every single year, which means that the time that robots take to do the operations, it needs to be very quick. In our case, for each one of the stations, robots will do the work, but the station, the time that the part stays in a specific station could be in the hours. So it could be 6 hours, 12 hours, 8 hours, depending on the number of things that need to happen there, which in turn hinders the amount of aircraft we can put out every single year, where we're talking very different numbers. In our best years, this industry has put 1,000 to 2,000 aircraft out, whereas the car manufacturer, the car industry can put out millions and tens of millions of cars all combined, which means that the speed of the things they do is really way ahead of what we can do in the industry. But the main thing there is that all robots need to be more intelligent to understand where they need to do the work, and in turn that makes them obviously slower to make that decision.
Okay. When you talked about the accuracy part, I was surprised that humans are more accurate, or they can do the job better than robots. Or you say the robots just need a lot of sensors and technology on top to be as precise as human beings. Is it like that?
Not quite. So I think it's a little bit of both. Obviously, humans cannot be as accurate as robots, but we have systems that will help the humans complete the operations in an accurate manner. Like we can put templates on the areas that the human don't need to think about where the drill needs to go. As long as they insert the drill in a specific hole in a specific sequence, that will the operation will be achieved. In the case of robots, not only they're slower, but also like you said, they need better sensors to do this. If we were to use these templates with the robots, now we're talking about even perhaps another level of complexity here, because as a human, if you need to insert something in a hole that is just the size of the thing you're inserting in, you may not think about it, but you're basically putting the drill inside of that, and then feeling whether or not you need to push in a specific direction to get it all the way through. The same thing needs to happen on the automation side. The robot needs to do it the same way. In order to enable the robot to do it the same way, not only needs to, visually find the hole, for example, and then once the drill is about to be inserted, you need some kind of force control to understand how you need to wiggle in that drill into that specific template. So all that takes time, because you need to be careful. Not, the robot is a very strong piece of machine. If you don't control it appropriately, you will damage something. Something will break, and the robot is not going to be the first thing that breaks. It's very sturdy too. So most likely you will damage the tool, the tooling, or the product, and that's the last thing that you wanted to happen in this sort of situation. So you need to be very, very careful, and being careful means doing things appropriately and taking the time to actually do it. But that time also adds up, and so it's always very difficult to make sure that the robot is. It's difficult to make obviously to make the robot work at the same speed that humans can do. Humans are really good at what they do. I mean, if I may say so. But
this is great to hear. Okay, understood. So you say there are different challenges that need to be solved to get more and more robotics into more and more use cases in an aerospace company. I summarize it like that. Marco, in our preparation call, you said on the other hand side, there are low-hanging fruits. So low-hanging fruit use cases, I would say it like that. where robots are already pretty good in. Could you describe it a little bit better?
Yeah. So the one thing that comes to mind immediately is logistics. Um, Logistics is the kind of thing that nobody thinks about, but the moment it breaks, everything comes down crumbling. It's like your internet connection. You don't think about it until you don't have a connection. But the logistics aspect of everything, especially on any manufacturing facility, is vital. Making sure that all materials are delivered to the appropriate point of use on time. Um, it's crucial sometimes to the way things are being put together. Um, in aerospace, being able to deliver parts, we obviously so there's several aspects to this. So if when you're manufacturing the components, fuselages or wings or HTPUs, BTPs, make sure that the operator or the robot in this case, either one, will have the appropriate number of tools, on tooling or fasteners or cutting, cutters for the drills, et cetera, et cetera. All the material today is very likely to be delivered by hand. There's actually people moving around, trolleys here and there, making sure that everything gets to needs to go. Um, but not only that, but also sometimes the operator is the person that needs to take care of, to find the tools and the materials that person needs to actually do the work. In doing some studies, we found out that operators in general spend 25% of their time walking around, just trying to find the parts that they need to complete their job. And if you think about it, most of the accidents happen when people move around a lot. They trip on things, they go up and down stairs. So basically, by automating all this, you most likely be taking care of also the lost time incidents that could happen in a plant like this. Um, so robots that sort of things, we get thousands of parts coming in every day, and so having automated systems that could unpack the parts, check them for quality, sort them, store them, and then deliver them to the point of use or where they need to be utilized would be excellent. And I think that it's one of those things that takes obviously a large capital investment to actually get it to work or get it implemented. But the benefits of doing something like that are massive. Um, not just in what in the agility of the operation that you're doing, but also, like I said, on the safety of people.
Okay. To summarize that, on the one hand side, we have different challenges which are not solved yet, where humans are just better and they are doing the job still. Then we have some low-hanging fruits use cases like logistics, where robotics are already pretty good and they are doing the job. And now the big question is, how can these challenges be solved? And at the beginning of the show, we already mentioned AI, and you talked about the smartness which is in AI, and probably this kind of smartness could go into the robots, to say it in that simple words. So let's dive a little bit deeper into that. How is the current state of AI and robotics, and how do you see its future?
Um. So today in the industry as a whole, in the robotics as a whole, I think that it's a very big promise. Being able to install these AI agents into robots that can do things. Um, like you said earlier today, like there's already been demonstrations on YouTube and demos that show the demos with robots doing things are pretty amazing, right? So
Mhm.
not only the robots are able to understand what you're saying, but also do an action based on that. I think that's pretty remarkable. Um, I still see a little bit. I still see a bit off. A bit of a way to go to come to an industrial setting. But clearly the leaps that we're taking now are far more important than we've done in many years. So absolutely yes, I think that this is going to happen. If I combine that to the previous thing we discussed about logistics, I think that would be amazing to have AI control this from a top down level, understand, the fleet management, where things need to go and when. So that could be really, really interesting. And because it's not touching the product, that could be something that could be easily implemented, right, without too much trouble. It's about operations more so than anything. In other areas, though, I think we're still uh, lacking the proper legislation to actually get it to work. What I mean by that is we still cannot allow a complete AI system, or because a complete AI system effectively is a black box. You don't know how that system is. Um, you set up the system in a specific way. You train it, but once it's trained and still learning, there's a point there in which you don't know exactly anymore what is
Yeah.
inside of it and how it's reasoning what it's doing. So if we let a system like that, uh, let's say drill a fuselage, like let's take an example of, okay, we have this fuselage, we give that to an AI and have the AI think about and the best method to drill it. Um, and every time we let it do that, the problem with doing this is that we lose traceability of the output of the product, right? And for for regulatory reasons, we need to know how the drill was specifically, the wing was specifically, or the fuselage was specifically drilled. In case there's an issue, or any sort of thing that needs to be repaired, we need to know we need to do an investigation and know what happened. We will lose that capability, and so today that is not possible. Right? Obviously, there are technical reasons still why we couldn't do it. Um, Perhaps the one that at least in my view, that prevents them from happening is the regulatory framework around it. Um, but that doesn't mean that it's not going to happen in the future. I think that we're taking the appropriate steps very carefully in order to understand how this would be made. Not specifically drilling or fastening or doing things like that, but I think there are other operations that could benefit from doing this. And obviously, like I said, the legal framework around it, and with a regulatory body, needs to be also in place. Things like visual inspection, or inspecting parts from in constrained spaces and things like that, could be. I see it as probably as a very good first use case for this sort of system, using um, visual recognition of what's happening inside, in case there's any material left inside, or anything that is not well done, something that is not sealed, etc. So I mean, I can come up with many options there, but I think that that will be not necessarily less dangerous, but less risky, because you
Mhm.
can still check it with a human afterward, especially at the beginning, to make sure that everything is done appropriately.
If you see that big progress right now in AI and in robotics, do you think that progress will just continue and they will now just get better year by year and overtake more and more use cases? Or do you think that there might be a plateau at some point where probably the big hype is over and we see, oh, there are still some things which are not solved and the technology is not continuing to be better? Like we had, I'm not an AI expert, but I know that some decades ago we had already a big AI hype, and then there was the AI winter, and nothing worked. So, how was your view on that?
Yeah, I'm of that exact mindset you just mentioned. So what was old is now new again. You're absolutely right. So all these things about reinforcement learning, AI, and all that used to be very
Yeah.
popular in the 80s and 90s. The very prime example of this is autonomous vehicle.
Hmm.
We've been driving autonomous vehicles autonomously on the streets since the 80s. This is the first time that actually happened. It's a sort of technology that looks feasible, right? And it benefited greatly from advances in technology like microprocessing power and things like that. But ultimately, in my view, got stopped by, once again, the regulatory framework around, because of really good reasons to why make sure that we're regulated appropriately. I think the AI is going to continue its current trend for a few more years, but I do feel like you said, I think it's going to plateau at some point. Not because it doesn't have
Uh-huh.
any more capability, but we keep creating these new systems, these new things, without necessarily thinking about the actual use cases in which they're going to be useful. And I think that nobody is looking seriously about how this can benefit manufacturing. We're looking at the way we're looking at it right now is from the end user perspective, right? What you see today, your chat GPTs and your other tools are for the common user. It's a democratization of the
Yeah.
of the of the tools for everybody, which is going to be great. It's going to have a great impact on what we do in the future. But until we take that in for manufacturing and for use cases that allow that technology to explode into a specific industry, think that this is where the AI will stall a little bit in terms of, okay, we got to the peak of how good ChatGPT can be, right, in the future, and you will add more features, but not necessarily be more intelligent. Well, I think that ChatGPT gives a great impression of intelligence, but it's not. It's basically it's using statistics to guess the best, what's going to be the next word in that sentence, which in turn is great because it does simplify things for human beings. However, you know taking that one step further, and adding more layers to that, but that will be great when it's dedicated to a specific use case, and that may be something manufacturing, or some sort of supervisory system to do something. We don't know that today. I think that I'm since this revolution started, what, about a year and a half ago, when it actually boomed out, completely. Think that the every so often I get impressed by something that comes out, like, okay, well, this now ChatGPT 4.0 can now speak to people and have a conversation with itself, and it's actually quite interesting, and I keep thinking about the possibilities. I've seen research already in the robotics field about using this capability to program robots. I myself was involved with one last year in which we took the manual of a robot and fed it to ChatGPT and had ChatGPT create programs to do something with a small humanoid robot, which was really super interesting. Like I said, it simplifies the task of the researcher, but these are in the initial steps. We still haven't gotten to that quantum leap on doing something really, really impactful for the industries.
Okay. Interesting. So there are still a lot of steps to do to make AI more useful for manufacturing. Marco, unfortunately, we are already coming to the end of this episode, but I would like to stay in the future and ask you the final question. How do you imagine uh, how will the factory look like 10 years from now? We talked about challenges, technology, AI. How will it look like 10 years from now from your perspective?
I think that it's easy to imagine a factory that has only machines in it. I think that's what science fiction has taught us is that machines can do everything for you. I think there's a dream about coming to a factory where you see no humans at all, and
Mm.
there are industries in where this is possible. If you go to, I've been to factories in Japan in which there are robots making robots, and there's like 1,000 robots making robots, and there's like 5 humans, five product line managers, you know, walking around making sure that everything runs flawlessly.
Yeah.
Um, I don't believe that every industry will be able to have a factory like that. We still depend too much on the expertise of humans to actually do this. Humans are too valuable in the end at the end of the day. And I don't believe that robots will completely replace humans long term. I think what's going to happen is that robots will take over the jobs that are pretty dull. The jobs that humans may not want to do anymore, and let the humans do what humans do best. Use their creativity to bring new systems or create new systems to do more interesting work and generate more product. Towards the final user. Um, there will be, obviously, with all these capabilities that we've talked about over the last half an hour, there will be more and more that the robots can do. But I really don't believe that the robots will be able to overcome human ingenuity long term. This is something that only humans can do. My job as
Okay.
a roboticist is to make sure that I support that journey, and that the robots that I can put in the factory together with my team can can only enhance the job that the humans are doing. Um, yeah. So to go back to your question, I think that there will be a combination. You will see more automation systems. I'm confident with that, especially on very dedicated tasks. But you will always see humans around, not only supervising what the robots are doing, but also, like I said, making sure that we do things in a more clever way. So there will always be a dependency relationship there. Humans will need robots, and robots will always need. I don't think there's one or the other sort of situation.
Yeah. Thanks for your look into the future, Marco. That was really, really inspiring. Thanks for that episode. I learned a lot.
Thank you very much for having me. Appreciate it.
Thank you, Marco. Bye-bye.
Bye.